So the problem that we'll be looking at today is the two-sum problem. It's a very famous problem. So let's understand the problem. So given an array of nums and an integer target, we must return the indices of the two numbers such that they add up to the target. And what are the cases that we have to keep in mind? That there's exactly one solution and we may not use the same element twice. Okay, so let's take an example. If this is the array and this is the target 9, so we must return the indices of two elements from this array which add up to 9. We can clearly see that 2 and 7 add up to 9. So we return 0 and 1. Okay, similarly the target is 6. We can see that 4 and 2 add up to 6. So the indices we return are 1 and 2. Okay, so how will we approach this problem? Okay, the first solution that comes to mind is obviously the uh, simple brute force approach. That is that, let's say we iterate through the array for I is equals for I equals to 0 to n 0 to n, and we take another loop of j, let's say for j equals 0 to for j equals, let's say, I to n, right? And we check. That is, let's say for the first example, let's say we have this array 2 3 4 2 3 2 7 11 15, right? And the target is 9. Okay, so initially I equals to 0 and array of I is equals to 2, right? And j equals to I equals to 0, right? So we can check from j plus 1. So no number is repeated twice now, so we don't have to check if 2 plus 2 will obviously not equal to target. So we can check j from I plus 1. So j is equals to I plus 1, that is 1, and we'll check if array of I plus array of j is equals to target or not. If it is equal to target, we return the indices I comma j. Got it? So what will happen? I is at 2 and j is at 7. It will check if 2 and 7 is equal to 9. If it is equal to 9, it will return the indices. It worked for this case. Okay, so let's take another example, which is 1 2 3 5 4, and the target is, let's say, 6. Okay, so here I will first start at 1 and then j is at 2. Does the sum equals to 6? No. Then j is at 3. Does the sum equals to 6? No. Then j is at 4. Does the sum equals to 6? Then j is at 5. Does the sum equals to 6? No. It's at 4. It doesn't equal to 6. Then the loop of j ends. It will go back to the loop of I, and then I is equals to 2. And then it will again check j for 3 4 3 5 4. Similarly for I equals to 3, it will check for 4. Once it checks for 4, we can see that 2 and 4 make up 6. So we'll return I and we'll return j at this point. So 2 plus 4 equals to 6. Return I comma j. But as you can see, this approach takes a lot of time, and the worst case scenario is the time complexity for this algorithm is big O of n plus big O of n times big O of n minus 1, which is equivalent to somewhat big O of n square. So what better approach can we look at? The optimal approach that we can look at is, for example, using a hash map. How exactly will a hash map work? So we have to understand this thing first, that if we have given an array 1 2, let's say for example 1 2 3 4 5 and 6, right, and 7, and let's say we are looking for a sum of 12, which will be given by 5 and 7. Okay, so we know that up till this spot the sum is x, up till this spot the sum is t, and this middle sum is x minus t. So if we have x, we just need an x minus t to reach the target. Or let's say we have x minus t. You understood this part? If we have a sum of x, we just need this extra bit to reach the target. If we think of it from the other side, if we have x minus t currently with us, we must check if we previously had x. Sorry, this will be t minus x. If we have t minus x currently with us, we must check if we previously had x. If we previously have already gotten x, then we know that x plus t minus x is equals to t. We have the target. Okay, so we have to store something and the index. So we have to store something and the index. What does this tell us? That we have to use a hash map. So how will it work? First, let's initialize a hash map. We'll use an unordered hash map because it is faster. We don't need an ordered set for here. We'll do something. Right. What will we do? We'll initialize another variable, that is integer, let's say a, and a will be initialized as target minus array of I, nums of I. Right. And we'll now check in the hash map, that is if mpp find, let's call it remainder, right? So we know that if we find the element in the hash map, it will not point to the end of the hash map. We know that if, let's say, we have an hash map this 1, 2, 2, 3, 4, 5, the end points to somewhere here. This is the end of the hash map. If we are looking through the array 1, we did not find 2, we did not find 4, we did not find. If we did not find, it will point to the end. And if we found it will point to the number. If we are looking for 4, it will point to 4. Okay, that's how it works. If it is not pointed to the end, that means we found it, we will return the index and the I value. Okay, but what if we don't find? We have to put it in the hash map. That is mpp of nums of I equals I. That is how we put it in the hash map. Now what if we do not find anything at all? We will return, I know it does not say in the question return -1, but if we don't find, we always return -1. So that's the approach. Let's see how it works. We'll run it. It's accepted, submitted, it's done. Its time complexity is big of n, which is much better. Okay, so I'll just show you this example. Let's see how does it work. I have already written the code for you here. So let's say we have been given an array, this array 1 2 3 4 5 6 7 9, and the target is 15. Okay, and this is the indices. Currently, let's say the hash map does not contain anything. Okay, for I is equals to 0, nums of I is 1, and what does our code say? That remainder is equals to target minus nums of I. So remainder is 14. Is 14 present? No, the hash map is empty. Then line number 14, or this line is not executed, which is corresponds to this line. So we go to line number 17. That is, we add it in the hash map. That is mpp of I is equals to 0. So the hash map will contain now 1, 0. Right? Now I plus plus I becomes 1. For I is equals to 1, nums of I is 2, remainder is 13. Is 13%? Obviously not. We'll input the new location. Now similarly for I is equals to 2, so on, and if we continue doing this, the hash map will look like this. For I is equals to 5, that is when the pointer is at 9, we know remainder is 15 minus 9, that is 6. Is 6 present? Yes, we can see that 6 is present. So we return I is equals to 5, and mpp of 6 is 3, because 6 is 3. So we return 3. 1, 3 is the answer. That's how it works.